Hi, and welcome to another CS tutoring session. I'm Anya. I'm a student at Berkeley, and I'm here to help you understand computer science principles a little bit more thoroughly through a mixture of both conceptual explanations and practice problems. If you have any questions, feel free to type in the chat as we'll be monitoring that. And as new questions come in, I'll be able to help address that and give an explanation. So what we're using over here is a Python IDE, which is essentially a web interface to practice coding without actually using the terminal. So the first kind of concepts that we will be going over are covering basic functions and loops. So going through these Python problems will help strengthen your understanding and go forward with more object-oriented programming and build upon this as you go in more advanced computer science classes. So first we'll start with some basic function. The first problem asks us to return the square of a number. So what do we do when we have to multiply a number by itself? It's typically just n times n. So if you're having trouble with functions, you have to understand the input and the output. In this case, the input is the number n, which could be anything. It could be 2, it could be 3, it could be 4. And we have to write a function that's able to generalize any number that goes in. And so in this case, since we're squaring it, it would just be n times n. So for example, 2 times 2, 3 times 3, etc. For summing up even numbers in a list, we need to loop through the list. And in this case, since we're doing a function, we have to make sure that if it repeats, it works over and over. So what we would do in this case is if we have n, we would just multiply it by itself, which is n. So now if we were to run this program, we can open another practice one, input in whatever we want. So for example, if we want to print out the result of square 2, we run this and we get an output of 4. You could try it with 3. We'd run that and get the output of 9. So that kind of explains how when we have something that needs to be done repetitively, we can write a function for it. The next problem we'll be going into is learning how to write a function that returns the last element of a list. So something really important for you to understand is list comprehension. Whenever we have an array, for example, if we have 1, 2, 3, 4, each element is basically able to be accessed through something called an index. So what Python does is it uses zero indexing. So what it would do is, for example, if we wanted to access if we wanted to access number 1, what we would do is if we have this list, we would take list and index 0, because zero indexing corresponds to the first item. If you print that, you'll simply get 1. So that's kind of the same principles that we want to use when we're kind of figuring out how to return the last element. Except in this case, since we're generalizing it to kind of any sort of list, you have to take into consideration that you don't know what the length of the list is. So this is where we have to use operators called splicing. And we have these kind of inbuilt functions. So for example, if we know 0 is for the first element, then if we want to access from the back forward, we start doing things called negative. So -1 would be accessing the last element. So kind of as we did before, an example to explain how this looks. If we wanted to index the last element of this, we would do -1. Yeah, and that gives us an output of 4. So now that we know that in order to index this input, which is our list, we simply have to put in -1. Since every time it gives us a list, it doesn't have to know the length. All it has to know is what the second to last element would be. So I see in the chat, it's asking if there are any C++ sessions. So the primary language for CS would be Python and Java. So that's kind of what we're going to be focusing on. As we're building up foundations, maybe in later sessions, we'll go into looking into C++. Thanks, Elizabeth. So now we'll be going on to our next problem in understanding list comprehension. So this is a little bit more complicated than the one we just did, because in this we also have for loops involved. Basically what a for loop does is it makes it easier to kind of go through a problem that's repetitive and understand that, and then be able to extract whatever insights you want and kind of automate that process. So what we're doing here is we're defining the maximum number that we want to get from a list. So the first thing that we're doing is we're making a variable called maxVal. Note that when you define a variable inside a function, you can only access that in the function or if you return it. If we didn't actually return maxVal, then that variable would be lost outside of the function and we wouldn't be able to actually get what we wanted from it before. So it's very important to consider what you want your input and your output to be in the function. In this, since we're trying to get the maximum number, we create a new variable called maxVal, and we also make sure that we're returning that same val. So what we have to do is first we make it fixed onto the first element, which, as I went over before, the first element, in order to get that, you have to index 0. So once we actually have that first element, what we have to do is go through each element in the list. So as I mentioned before, we don't actually know the size of it, which is why when we're kind of going through each element in the list, we make a for loop and we don't set the range. Instead, what we do is we tell it to go through every single item in this list itself. That's what this for num in list function is doing. Then what we say is that if that number is compared to the previous number. So in this, there's multiple options that it could be. It could be greater than, equal to, or less than. Since we're trying to find the maximum number, we want to see if a number is greater than the one that came before. So what we would do in this case is see if the next number that we're looking at is greater than the number that we've already defined, then we want to set it equal to that number. So for example, if we're going through this list, the first thing we do is set max equal to 10, because 10 would be corresponding to index 0. The next thing that we would do is go through all the numbers in the list. So the first number is obviously 10. That's not greater than, so we keep that the value. The next thing we do is go through the next number, which is 20. If 20 is greater than this, what we set up above, then we change that. So we see that 20 is greater than 10. So then we set our maxVal variable to 20. And now we keep going through the list. If we look at 5, 5 is not greater than. And then finally we go to our last number, which is 30. We see that 30 is greater than maxVal, which was previously defined as 20. And then we replace that value. So now that we've gone through every item in the list itself, we want to return the value that we saved it as, which in this case is 30. So what this would do is print number 30 because that's the max variable in here. Yeah, so now if you wanted to experiment with this, add a couple larger numbers and see if it would still work. Imagine you put the largest number at the beginning. What do you think the output would be? It would once again be the largest number, since nothing else is able to actually replace the value that it was already set as. Kind of what this shows you is in a for loop, it is required to go through every single item in the array. And that's the only way that we're able to kind of check that all of our criteria has been met. Now for our next problem, we want to write a function that returns the length of a string without using len. So for some context, Python already has a len operator. What this does is it's able to take the length of what we're using. But in this case, since we're focused on for loops and understanding how to kind of write these and make sure that it increments correctly, we don't want to actually use that length function. So the first thing that we have to do is define the function. The function that we're defining is string length. And you have to think about the input and the output. Once you've defined your function, you want to know that your input is the string that it's taking in, and the output is the count of that string. So as we did earlier, you have to make sure that if you have something that you're returning, you define it inside the function itself. So the first thing that we're doing is setting count equal to 0, which is kind of the base case. This is, the like non-negligible thing is like, that the string length is going to first start at 0 since you haven't actually began counting anything. Once you see that the count is 0, you want to start figuring out what you want your for loop to look like. For each character in blank, increase count by 1. So when are you actually going to be increasing this count? It's basically when you're going through each item of the word that you're looking at. So for example, if we have hello here, the first count is going to be set to 0, since the for loop hasn't started going through anything. Then we wanted to count each character in hello. So for example, if we have H, we wanted to add 1 to count, go to the E, add 1 more, go to the L, add 1 more, and so on until it hits the end. So over here, we have to make sure that it goes to the input, which is the string that we give it. So that would be for character in S, count plus equals 1. So now the next thing that I want to kind of bring up and explain is how we're able to increment and add count. So if over here, if we were to say count is equal to 1 instead of plus equals to 1, what do you think would happen? What would happen is basically it would just replace the value of count with 1 every single time. What this is doing is it's taking count and it's setting it equal to 1, and no matter how much it goes through the for loop, it would stay at that. So that's why we want to make sure that we increment it, and then once we increment it, we also want to set it equal to that new value. Now, if we try to run it, it would give us 5 because that's how many times it's gone through each of the loop and the count that it's changed by. If you want to actually see this, what we can do is we can print the count inside the for loop itself, and it would show us how every time it goes through the loop, it changes the number. So from 1, it goes to 2, 2 goes to 3, 3 goes to 4, and then finally it goes to 5. And then that's what it outputs at the end, since that's what we are looking for. I see that someone from TikTok had a question, which is this stats? No, this is computer science, more specifically object-oriented programming. Now for our last question in looking at for loops for list comprehension. What we want to do is write a function that returns the sum of numbers in a list. Once again, the first thing we do is make sure that we use our key statement, which is def, which defines the name of our function. When you're defining the name of a function, you want to make sure that it's something that is easy to understand. And in this case, it's sum list. So because we're able to kind of think about the name of our function, the next thing we want to do is look at our input and output. So our input should be the list that we're giving it, and the output should be the total sum of numbers in that list. So this is different from before because what we're doing is we're actually adding each of these values to each other instead of just counting the list itself. So as we did before, we want to make sure that we define our base case. Our base case in this case is that our total is equal to 0. If we don't have anything to begin with, we have to make sure that we set this variable here, or else we're not going to be able to return anything at the end. Another thing to note is that you have to return a variable once you exit the for loop. That's what each of these indents are for, showing the step and progression of the code. First, what you do is when you have a list, you want to go through each number in it. And basically, num is what's in charge of iterating through the list itself. Since we have our total equal to 0, what we have to do is basically increment and change total every single time that we go through it. So in the previous problem, we changed our variable by 1 every time because we were keeping track of counts. But in this case, we do not care about the counts. And rather what we want to do is increment by the actual value of what we're looking at. So imagine you're going through this list. The first item that you have is 1. You want to set total equal to 1. And then when you go to the second item, do you want to add 1 to total or do you need to add 2? So in this case, what we have to do is increment total by num each time because that is how we're progressing through it and making sure that we add the actual values itself and not just the counts of each of them. So then what we do is we increment total by plus equal to num to get the final value, which in this case is 10. Say you wanted to experiment and not start it at 1 this time, would it still work? Yes, it would, because it's not contingent on it starting or ending at any values or looking at the count itself, but it's looking at the inside of each of them and making sure that it adds it to the total. Once again, if you have any questions, feel free to type it in the chat and I'll address them. Our next question is looking into writing a function that removes all even numbers from a list. So this is a little bit more difficult since we haven't done list comprehension before. But kind of the way that you'd explain it is in these for loops that we've done before, they take up a lot of space for no reason. And instead what we can do is put it into a list or an array format. So what this would look like if it wasn't in a list format is it would say define. It would take in the input of list, and then we would do for num in list if blank, return num. So see how this list is a lot more optimized than this way of doing it. When you're writing long programs of code, you want to make sure that your code looks organized, and that way, when you're calling something again and again, it's easy to debug and organize your program. That's kind of the importance of list comprehension. So if this format is confusing in your head, you can always view it like this, and then that will help you understand what you should include in here. So what do we have to think about here? First, as I mentioned before, our input and our output. So we know that our input is the list itself, and we know that our output is also a list, but without even numbers. So as you see, there's no base case in this because what we are doing is modifying the list directly. Because of that, we don't have to make anything. For example, before we would have total equal to 0. We don't have to do that in this case since we are directly modifying the list that we're giving it. So what we're doing now is we have to think about, okay, now how would we actually remove the even numbers from a list? The first thing you have to think about is how do we identify if a number is even? This is where we introduce something called the modulus operator. So this operator basically is able to divide a number and tell you if there's a remainder or not. So for example, if you want to print 2 mod 2, what do you think the output of that would be? 0, exactly. Because there's no remainder, when we're dividing an even number by 2, it would give us 0. Now say we wanted to change this to 8, our answer should also be 0 because there's no remainder when you divide it. So say this is an odd number. Say we give it 3. Our remainder would be 1. If you gave it 5, our remainder would be 1 again. So now that we know about this modulus operator being able to detect if a number is even or odd, we have to basically use this in figuring out how to remove the even numbers from our function and the odd numbers. So now that we have our function remove evens, which takes in the list, we want to basically say where we want to actually put our condition. So since we're having our list be here, why don't we first try writing it out here so that it's less confusing? Basically, since we're going through each number, we want to see if this number, when it's divided by 2, if we say it's equal to 0, what is that going to do? That is going to give us all of the even numbers. But what we want to do is make sure that we remove them. So we want the list to contain all the numbers that does not have a remainder of 0. If that doesn't make sense, make sure you type it in the chat so I can help explain it even more. But since we're going through every number in the list, dividing it by 2, and seeing if the remainder is 1 or 0, we want our list to contain everything that has a remainder of 1 because we want it to contain all of the odd numbers. So if we convert that into our list comprehension over here, and then we run this function, we will be left with a list of only odd numbers, which include 1, 3, and 5. Say if you want to test this out even further, 2, 4, 6, 8, 5, you'd be left with only odd number, which is 5. Now that we learned a new way of list comprehension, we'll be kind of going into this further. In most upper div CS classes, you'll be expected to write your for loops in this list format. So starting to get comfortable with this is very important. Now that we have a understanding of that, we'll be going into list splicing and more operations that we would do with an array. So the first thing we do is write a function that returns the first 3 characters of the string. So once again, when we're writing a function, there's like 3 steps. The first is the function name itself, which we're defining as first 3. The next is the input. So what do we want our input to be? We want it to be the string itself. And finally, what do we want our output to be? We want it to be the first 3 characters. So we learned some list splicing operators before, which was being able to index the last item through -1. And we learned some math operators as well, which was modulus operator. The next thing we'll be doing is understanding the involvement of list comprehension and how we're able to extract certain portions of a string. So the first thing to learn is how, if you have a string, for example, hello, and you want to index say the first 2 letters of it, what you would do is, since we learned before to index the first one, you would do 0. To index the first 3, you use something called a colon. And you use that to kind of say, okay, go from the start up until the number 3 or the 3rd item. If you print that, you get HEL, which is the first 3 items in the string. Now, if you want to do the other way around and you want it to start at item 2 and go until the very end, you put whatever number you want at the beginning of the colon. So for example, if I wanted to do these last 4, I would start it at 1 and then go until the last 4. And note that the reason I started as 1 is because of what we talked about earlier with Python having 0 indexing in arrays. Starting at 1 is the equivalent of starting at 8. Once again, if you have any questions on that, feel free to type it in the chat. Since we've kind of explained how list operating and splicing works, you have to think about what we need in this problem. Since we're looking at the first three characters in the example that I did before, we have to figure out where we want to put a number in relation to the colon. Since we want the last three, we want it to start at the beginning and we want to give it an ending point, which would be item 3. If you want to experiment with different letters, word. If we put in this, it would give us WOR. So this is kind of a very useful operator, since when you do this, you can also kind of splice and combine different words together. For example, if you want to give it like hello and then a name, you can do hello plus and then splice whatever portion of that name you want. So these kind of things are very important when you're dealing with changing and mutating strings. Once again, if you have any questions, feel free to type in the chat. Our next one is looking into writing a function that checks if a number is in a list or not. So far, we've only been doing changing and modifying. We haven't actually been able to look at how to check things. So what we have to do is first take into consideration an example that we might have. This is what our example might be. So if we have 1, 2, 3, and 4, and we want to check if 3 is a part of this, how would we do that? So another operator that we haven't gone over in Python yet is Booleans. Booleans are essentially when we want an output of true or false. So in this case, we have to also think about our inputs and outputs. So far, we've only had one input, but in this case, we have two. This is because we need to check if the number is in the list and also give it the list itself. In our example, we're giving it the list and then we're also giving it the number to check. So in order to put that into perspective, when you have our function, you have to make sure you look at what the two inputs might be. And also the order is the way that it's going to go in when you're calling the function. So keep note of that as well. You cannot just give it in any order and have it imagine and figure out which one it wants to put first or second. So now that we have our list and we have the number that we're checking it with, we have to figure out what operator we would actually use to check if it's in a list. So this might come intuitively as you keep doing programming, but there's essentially something just called in. It's very straightforward, but it's something that you have to kind of memorize as you're going forward. This would simply see num in list, true or false, and it would return that value. So because 3 is in the list, it returned true. If 3 wasn't in the list, we would expect it to return false. So that's kind of how we use Boolean operators and checkers to go through arrays and lists and give us an output that makes sense. Moving on to our next question, which is building off of the previous one. We want to be able to count how many times a number, a character appears in a string. So once again, you have to think about what you want the inputs of this to be. You want to first take in the string and you want to take in the character that you're trying to count and figure it out. So for example, if we have banana, we can't only give it banana, we also have to give it the string that we're trying to compare it to, which in this case is A. We want to count how many times A appears in banana. Now, as we're going through this, since we're doing counts and not modifying the actual value, you have to define a base case, which in this case is where counts begin, which is count is equal to 0. Our base case is kind of defining where we build up from. And so when you first enter the function, we haven't actually gone into the for loop, meaning that the count is set at 0. Then as we kind of go forward and we say for C in S, which starts our for loop. For each character in the string, and then we have our condition. So you have to take a step back and think, what do we want our condition to be? What should C be equal to? C should be equal to our character. So for example, if we start at B, we want to see if B is equal to the character that we're comparing it to. So if B is equal to A, then what do we do? If not, it just continues on with the for loop. So what we do here is we also have to consider what this operator means. So when we have one equal sign versus two equal signs, those mean two very different things, and they're very important to remember. The first equal sign is what we do when we are equating something, basically making a pointer from one thing to the other. In this case, we're setting count equal to 0, which is basically equating count to the value of 0. If we look for count, we'll see an arrow pointed to a box with a 0 in it. But what we're doing with two equal signs is it's more of a checker. We're seeing if the values are actually equal to each other instead of seeing what is drawing an arrow to. So if C is equal to character, then we want to increment our count by 1. If that's not the case, then we want to continue back and keep going through our for loop. So for example, if we have banana and we have A, we want to see if A is equal to B, which is the first letter, increment count by 1. So in this case, that is not true. So then we keep going through the for loop. We get to A and see, is A equal to A? True. So then add count 1. So now if you want to kind of see how this works, what we can do is we can print count after each if statement, and that'll show us how this operates. So you see how there are 6 letters here? If this was true all 6 times, then we would have it printed out 6. But we only have it printed out 3 because there are only 3 A's in banana. If you have any questions on that, feel free to type in the chat and I can elaborate. But that's kind of how we would use our checkers to go with the arrangement of repetition in a for loop and seeing how we would increment our count. Continuing forward with our theme of checking in a for loop, we want to next write a function that finds the index of an element in a list. So this kind of combines a couple of our questions. The first is how we would identify if an item was equal to the other. The next is making sure we look at indexes and not values. And the third is understanding how many inputs a function should take in. So I saw someone in the chat asked if this is SAT. So this is not SAT prep. This is rather what you would expect in an AP CS exam or an introductory CS class. This is what the problems in the homeworks and the exams would kind of look like. So the first thing we have to do is actually define our function, and we want to make sure we give it a good name. In this name, we would define it as find index, and in this index, we take in 2 inputs. Since what we're doing is we're first taking in the list itself, and we're also giving it the index that we want it to find. Note the difference between value and index, and when we're looking at this, that'll be the main part in the confusion that students go through when they're dealing with problems like this. So notice how in this function, we've introduced a new vocab word basically. So since before we just went through the actual values itself, we never actually had to get the numbers in the list itself. So what this range function does is it gives you the numbers going all the way up from the beginning to the range that we want to see. So if we actually give it 3, it'll give us the range from 0 to 3. So what we want us to do is give us the range of the length of the list. So for example, if the list is 4, we want it to give us 4 so that we can start going through each individual item in the list. So for example, if we have the list of 10, 20, 30, 40, and we're indexing it, we want to see if that item is equal to the target. So if we have 10, 20, 30, 40, and we're going through, okay, the first is I, we want it to index 0. Since, as we saw here, range gives us the first, which is 0, that would work in giving us the item 0 of list, which is 10. We see, okay, is 10 equal to 30? No. Over here, we wanted to reach the condition. And then once we reach that condition, you want us to actually get that index. So you have to take into consideration what the index is represented as in this problem. In this problem, I is what is represented as the index, since that is a number where we start at 0 and we end at whatever the length of it is. If we were to actually go through each and every item itself, then that would be 10, 20, 30, 40, as opposed to 0, 1, 2, 3. This is a very important distinction in this problem that trips up a lot of students usually. So you have to make sure you understand what is being asked for and what you have to return. In this case, what we have to do is return letter I. Letter I is the actual index of the problem, and that is what we're looking for in this expected output of 2. Since if we're trying to match 30 to where it is in the array, it would be 0, 1, 2, item 2. Say you wanted to change this to 40, what would that be? 0, 1, 2, 3. Understanding these concepts of range is really, really important, since range and index versus value is going to be a big thing going forward. Now, this is kind of building upon the previous problems that we've done with list comprehension and understanding how to reverse a list. So far what we learned was that if we have one colon, that'll start at the beginning of the list and then end at wherever you give it an output. The next thing that you need to learn is when you have 2 colons, you can give it 3 values. The middle value is going to be how much you want it to increment by, and the last value is actually where you want your list comprehension to end. So since we have reverse list given a list, we want to return going from the last one all the way to the beginning. So the last one is -1. As we went over before, seeing -1 is always going to be the end value, even if you don't know how long the list is. So for example, if you know a list is 1, 2, 3, 4, 4 values in it, then you can easily just index, okay, I want this value, which is going to be index 3. But imagine you have a list that's of an unknown kind of length to you. You would want to use -1 to kind of generalize the last value that you would get. So over here, what you do is consider where you want each of your colons to be and how you would actually go through the list. So in this case, what we want to do is return the last item in the list and increment by that, which is why you would use 2 colons to go through the list, return the last value, and keep going one by one down the list to give you your final returned output. I'm going to try this with a different example. If you do 3, 6, 7, 10, you would expect an output of 10, 7, 6, and 3. So that's kind of how you use this notation of colons to not only indicate where you want a splicing to start and end, but also how much you want to increment by going forward or backwards. So now what we'll be doing is learning a new data structure type in programming. So this data structure type is dictionaries. So what we've gone through before is a list. A list is a way to store data that is in a very easy to understand order with just one value corresponding to an index, which is defaults of 1, 2, 3, 4, 5, etc. So when you want to access a value by its key, so kind of when you have like your object and your arrow to the other object, you want to be able to identify either one from the other. And that's where we use a dictionary. So what you want to do in this dictionary is create a name and give it a value. So our key in this case would be name, and our value would be Alice. And as we kind of want to go forward and add more and more items, we can keep doing that. If we want to have a key be age, have the value be 25, have a city be New York, that's how you would do this. Another interesting thing that's very important to note about dictionaries is that the data type can be different. In most objects, the data type has to be the same for organizational purposes, but in a dictionary, the objects can be different, and it's something that's very, very useful in real life when you're working with data structures. So since we're defining our dictionary here, we have to think about how we would actually add, subtract, and index items from the dictionary. If we wanted to add, say, her address, we would do address, and then this colon is what actually equates the value to the key. So we would say address 234 Liberty. And then that creates a new object that points what her address is to the value address. So now if you want to actually be able to index an item from the dictionary, how would we do that? So as we learned before, we use brackets for indexing and getting that, input from the output. You would take in my dict and figure out how you would get Alice from it. To do that, you give it name, since the name is the key, and your output would be the value. As we kind of learned before, if we did list and we index 0, we would get item 0 from the list. So that's essentially the same thing that we're doing here, except we have a different data type and a different structure. So if we have my dict and we're trying to get Alice, we would use name to get that. There we go. Now if you want to try this with a different object, say you want to get her age, you would put age in there, run it, and that would give you 25. So if you have any questions, feel free to type that in the chat, and that'll help understand kind of how you're following along and understanding dictionaries. Our next concept or question is definitely a little bit more tricky and something that would for sure show up on a CS exam of yours. And that would be understanding how to write a function that swaps the first and last elements of a list. This is using a lot of the principles that we've covered, including indexing, list notation, and more. So we have to think about our inputs and our outputs. So in this case, we give it a list and that's it. We don't need a second input because we're going to be accessing the elements from the list itself. When we give it our input of list, we take in, okay, what is our item 0 and what is our last item over here indicated as -1. Since we have actually accessed our, first item and our last item, what do we have to do now? We have to change it. And over here, you see how we have our equating symbol again, which should be a hint as to what we're going to do is change what our item 0 and what our last item actually is pointing to. We want our item 0 to be pointing to our last item, which is -1, and we want our last item to be pointing to our first, which is 0. I can write it out so that it seems less confusing. So if we have 4, 5, 6, and we want our output to be 6, output to be 6 to 4. Currently, if you think about what each of these are, is if you index 0, that is equal to the value of 4. If you index 1, that is equal to the value of 2. And then if you do -1, which we know is equal to the last value, we get 6. But what we want to do is change the way that these arrows are pointed and have item 0 be pointed to 6 and have item -1 be pointed to 4. So the way that you want to do that is make sure that you understand how you would switch these two. In this case, it's very simple since we're simply taking an item 0, item 1, and swapping that. You would say list -1 and list 0. Since what we're doing is having this first item be associated with this and having this item be associated with this, as explained down here. So this is something that coding-wise is very simple, but conceptually it's something that you have to understand strongly before you actually output it. So say we want to run this function. And we want to give it a list that we kind of went over before, just 4 to 6. It would print out 6 to 4 because the pointers for each of these swap. The pointers for 0 goes to -1, and the pointer for -1 goes to 0. I hope that makes sense, and if you have any questions, once again, feel free to type it in the chat. Going on to our next concept that we touched upon last week was the concept of classes. So what a class is, it's basically another kind of type of object where it's self-defined, so it's really easy to kind of repeat it over and over as you need to kind of make objects again and again. So for example, this is a very common problem, which is creating a class person. We want to make a person that has a name and an age and have that be repeatable so that we can make multiple different people who all have different ages. For example, we could do this with class cat. Say we want to make different cats, we give it name, ages, and in order to define it, we would say the class, the name of the cat, and how old they would be. So when you have these, you have to make sure that you include self in the function to define it so that you know that that object is pointing to itself. This is something that isn't very intuitive, but with repetition, it'll make sense. Then going forward, when you start defining this actual function, you have to make sure that you have self.name and self.age. What this does is it takes in the object attributes that you give it, and that'll be how you're able to make a pointer to say, okay, these are my inputs and these are my outputs. You would say the output is name and the next one is age. So what this does is it makes it easy to call and understand the objects as you make it. So this kind of seems like you're just kind of defining something. Why can't you just, have it be name and age? Why do you actually need a class? Well, class makes it so that when you have attributes, you can also create methods, which are ways for you to actually do functions that act upon the objects that you've made. Going forward, we'll go more into that, and that'll help make sense as to why we have to make classes. Our next example is a more complicated function that actually sorts a list in ascending order. So this is something where we'll be using and understanding the inbuilt functions that Python has. So as we talked about before, Python had functions called len, range, um, and splicing operators. The next one is a function called sorted. What sorted does is it gives you the way to return a list in ascending order, and it's something that you'll be using quite a bit going forward. It's very straightforward and something that you should keep in mind when you're actually doing your examples, since it will save you a lot of time. And finally, we're going back to our Boolean operators to go through a function that returns true if all the elements in the list are unique. What we're going to be doing here is figuring out what we actually need to utilize for this and brainstorming how we would use our data structures knowledge to do this problem in an easier way. So what we want to do when we're checking if the elements are unique is turn our list into a set. A set is a new data type that only contains unique items. So for example, if we have an array, our array could contain 1, 1, 1, 2, 2, 3, 4, etc. But a set would have to contain only unique elements. So if you turn this array into a set, it would be 1, 2, 3, 4, 5. It cannot contain any duplicates or else it would be invalid. So what we're going to try to do in this problem is actually turn our list into a set. And the way that we would do that is first understand what we want our output to be. We want our output to be a Boolean, which is why we have this equal to operator. And then what we want to do is turn our list into a set. And the way we would do that is simply set our input to be the list, taking in. Then if we run that, we would expect true for the first one and false for the second one. Since over here we have 2 values, so our set would actually be only 3 versus our array has 4 values. That's kind of how you would check using data structures and not a for loop. So the reason that we are going to try to eventually do problems without for loops is because of the time complexity. This is a new concept where when we're doing any problem, you have to think about how long it would take and how much storage that would be. So if you have something that's all unique that takes in a list, what you want to do is basically see, okay, is there a way that I can do this without going through a for loop, comparing the first value to the next value, second value to the next one, and going so on and so forth. And the way you would do that is using a set, which is a much simpler process. It's simply turning one data type into another. Another example of turning one data type into another would be if you have an integer that is 5 and you want to turn that into a string. You would simply do str and give it 5 to turn that into a string. Once again, if you have any questions, feel free to type in the chat. Our next and almost final problem, according to the time, is taking a function that converts a list of strings into uppercase. So what we're doing here is we're going to start looking into more of the string operators. The string operator that we're going to be using in this is word.upper. What this does is when it takes in a word, it turns it into all uppercase notation. And once again, we're using list comprehension to go through every single item in this list without having our for loop be multiple lines long. If that is still confusing to you, we can write out how this would look like without that. For word in blank, return word dot upper. So now you have to understand, okay, what is our input and what is our output? Our input is list, and our output is going to be everything that is uppercase in that list. So what we want to do is do for word in list, return the uppercase of that word. So what this means is we do for word in LST, return word dot upper. Now if we try to actually run that, we'll get hello world turned into hello world. So now that we only have 4 minutes left, I just wanted to mention on the screen there's a QR code. If you guys want to scan that, that'll give you more information on these tutoring sessions going forward and any advice that you guys need. Now with our last problem, we're going into taking in a function that returns the factorial of a number. So essentially what a factorial is it's multiplying a number by itself, and it keeps going in that order. So for example, if you have factorial 5, it would be 5 times 4 times 3 times 2 times 1. What you want to do is, in order to address this, since the number goes down one time incrementally, we can use something called recursion. This is where our factorial function will call upon itself multiple times until it reaches our base case of 0. So for example, if we have n equals 5, we want it to go n equals 4, 3, 2, 1, and then eventually it is going to hit 0 and exit the function. So if we want our base case to be 0, we want to also think about what that would return. If we do the smallest number, which is 0, we would have it return 1, since that's the smallest factorial that we can get. The next thing we would do is return n times factorial, which is the function itself, but we would have to give it a new input the next time around. And what we want our new input to be is incrementing by 1 less than what we gave it before, which would simply be n minus 1. So it sounds very simple in writing, but actually understanding recursion is very complicated, as you have to think about all the different variables that go through it, where you want your base case to be, and what you want the actual work involved to be. Since we want to make sure that it goes down by 1 each time, we also want to make sure that we don't just ignore the base case. A common issue is that people go, okay, we're just going to go and keep going until it hits 0. But unless you actually define that, this function is going to error out. So when you actually run this, you'll be able to see what each of the values are. And what we can do as an intermediate step to kind of understand this is have it print n each time so you can see how the value of n changes. It starts at 5, then it increments by 1. So when you have it print, it'll go to 4, go one more time, it'll hit 3, and then 2, and then finally it will return when it ends at 1. And in the chat, someone asked, is this recursion? And yes, it is. This is recursion. This is one of the most commonly used problems to understand how recursion works. And yeah, if you have any more questions, feel free to type it in the chat of the next minute. But thank you guys so much for coming. Once again, there's a QR code if you want to learn more about this tutoring process and how Chegg is involved in all this. Thank you so much, guys.